All right, welcome to this explainer. Today we're diving into something that is just absolutely fascinating, highly complex, and frankly, incredibly high stakes. We're decoding the process of procuring heavy emergency vehicles from China. We're going to get into the precise engineering constraints, the wild world of global logistics, and the rigorous B2B workflows you need to master to successfully source these life-saving machines. Let's get right into it. So, let's start with a really intriguing question. How exactly do you buy a 16,000-liter fire truck from halfway across the globe? I mean, getting this wrong, it literally leads to severe operational failures or worse, dangerous rollover risks for the operators. But getting it right is a total game changer. It means incredible cost control, which allows municipalities and industrial facilities to dramatically stretch their capital budgets without compromising a single ounce of safety.
Okay, here's our roadmap for today. We're covering 1. The OEM manufacturing advantage. 2. The anatomy of a fire truck. 3. Municipal versus industrial configurations. 4. Breaking down the costs. 5. Global compliance and standards. And 6. The procurement workflow steps.
Kicking things off with Section 1, the OEM manufacturing advantage, specifically looking at scalable production. Direct procurement from Chinese original equipment manufacturers, or OEMs, gives international buyers massive purchasing power. We're talking about leveraging renowned commercial platforms from heavy hitters like Isuzu, Dongfeng, Sinotruk, and FAW. Because this industrial ecosystem is so clustered together geographically, these suppliers can source subcomponents incredibly fast, and that drives down overall production costs without sacrificing any structural quality. For you, the buyer, this means you get to fully customize the build, from the exact tank capacities right down to the specific storage layouts, all while keeping your capital expenditures in check. Plus, if you do your homework and properly vet your supplier for export and climate matching experience, you get a dedicated project manager overseeing the whole shebang, from the first CAD drawing to final delivery.
Moving right along to Section 2, Anatomy of a Fire Truck. This is where we engineer the beast.
You kind of have to think of this process like building a highly technical custom home. The commercial chassis, that's your foundation. It completely dictates your payload capacity and your driving stability. But here's the catch. You can't just bolt a massive, heavy water tank directly onto a rigid chassis. That's where the subframe comes in. The subframe uses these specialized flexible mounts to absorb torsional off-road stress so the truck doesn't just crack under pressure. And then you've got tank baffling. Picture a fire truck taking a sharp urban corner with 16,000 liters of water sloshing around in the back. That's roughly 35,000 pounds, literally the weight of 3 full-grown elephants, shifting all at once. That is an enormous amount of fluid kinetic energy. Internal surge baffles act as structural walls inside the tank to prevent that rapid fluid shift, which completely neutralizes those dangerous rollover risks.
Which brings us to the pump. When an emergency crew rolls up to a scene, firefighters rely on immediate, high-pressure pump activation. And that makes the power takeoff, or PTO, the absolute beating heart of the truck's operation. It's this vital mechanical linkage that basically steals rotational energy from the vehicle's engine and transfers it directly to the water pump. Honestly, if the PTO engagement isn't flawless, the mission fails. It's that simple.
And wrapping around all of those internals is your superstructure. Now, you've got to select this material really carefully based on your operating environment. If you're on a strict budget, carbon steel gets the job done, but it definitely requires aggressive anti-corrosion upkeep. Aluminum alloy is fantastic if you want to reduce overall vehicle weight and maximize payload margins. But say you're operating in a high-salinity coastal area. In that case, specifying polypropylene or PP tanks drastically reduces your long-term maintenance costs. And if you're dealing with harsh industrial foam transport, for sure you're going to want stainless steel.
Let's pivot to Section 3, Municipal versus Industrial Configurations. This is all about matching the truck to the threat. Listen, you absolutely cannot send a nimble little urban municipal truck to fight a volatile, heavy-duty liquid petrochemical fire. It's a recipe for disaster. Municipal vehicles are explicitly designed to navigate tight, restrictive urban streets, and they use medium-flow centrifugal pumps for standard structural fires. Industrial vehicles, on the other hand, are absolute heavyweights. They require massive chassis to support those 16,000-liter payloads, advanced foam systems for Class B flammable liquids, and high-velocity remote deck monitors so crews can fight intense heat from a safe distance.
Oh, and a quick side note here, not all response vehicles actually fight fires. Take the rescue tool vehicle, for example. It carries absolutely zero water. Its payload is 100% dedicated to technical extraction. We're talking heavy-duty generators, hydraulic extrication tools, and pneumatic lifting systems designed specifically for severe traffic collisions or structural collapses.
All right, Section 4, breaking down the costs. Let's dig into the financial matrix.
Looking at the numbers, you can see how prices just scale right up based on risk assessment and the apparatus class. A small water tanker for urban use? Very economical. It runs between $35,000 and $70,000. But as you scale up to a heavy-duty foam truck for petrochemical hazards, you're easily looking at $100,000 to $200,000. And an articulated aerial platform for high-rise buildings? That can push $500,000. One absolutely critical thing to keep in mind here: if you specify an imported chassis platform instead of a domestic Chinese one, it's going to significantly bump up these baseline costs.
But remember, the sticker price is almost never the final price. You have to factor in additional cost drivers. If your local standardization requires it, Chinese OEMs can totally integrate international pump brands like Hale, Darley, Waterous, or Godiva, but that directly hits your budget. Also, custom rescue equipment layouts will extend fabrication time. And finally, you've got ocean freight. These massive rigs usually ship via roll-on roll-off or ro-ro vessels or flat rack containers. Always, and I mean always, request CIF or FOB pricing terms during your RFQ. You need to know your total financial exposure on those ocean logistics.
Which brings us to Section 5, Global Compliance and Standards. Basically, how to actually secure port clearance.
Buying the truck is one thing. Legally getting it into your country is another. This is where doing your homework really pays off. Reputable, export-oriented facilities can engineer your apparatus to strictly meet major safety frameworks like the European EN 1846 or the American NFPA 1901 standards. But, and this is a massive but, pay very close attention to local emission laws. You have to align your commercial chassis engine with local environmental regs like Euro 5 or Euro 6. If you buy an incompatible engine, your multi-thousand-dollar asset is going to be permanently stranded at the destination port. Customs literally will not let it in.
So, to protect your investment, you've got to mandate strict quality assurances right in your contract. Ensure the facility holds ISO 9001 certifications. To guarantee tank longevity and prevent catastrophic leaks, demand automated robotic welding on all primary structural seams. No exceptions. Insist on specific hydrostatic tank testing and formal pump flow validation reports. And lastly, make sure all electrical systems pass 12-volt or 24-volt multiplex diagnostics. That's what guarantees extreme weather reliability.
Finally, Section 6, the procurement workflow steps, from RFQ all the way to delivery.
This 4-step workflow, it's your absolute gold standard to mitigate risk. Step 1. Lay out your exact application hazards, water capacities, and local regulations in a tech requirement submission. Step 2. The engineering team takes that, evaluates it, and sends back a configuration proposal with CAD layouts and a quote. Step 3 is production and QA. Usually a 45 to 90-day lead time. During this phase, demand extensive video documentation of the pump hitting its max flow capacity. Or better yet, hire a third-party agency like SGS to physically verify it. And step 4 is logistics and after-sales support, where you get your operational manuals and remote diagnostic protocols all sorted before the ship even sets sail. Oh, just a quick logistics tip for you. The standard minimum order quantity, or MOQ, for these specialized vehicles is strictly just 1 unit. However, a lot of savvy municipalities and industrial buyers will actually group orders of 3 to 5 units simultaneously. Why? Because grouping them perfectly optimizes those per-unit ocean freight costs.
So, as we wrap up this explainer, I want to leave you with this final thought. The margin for error and emergency equipment sourcing is practically zero. Knowing what you know now about flexible subframes, kinetic fluid baffles, and unforgiving global compliance laws, are you truly prepared to draft your next heavy equipment RFQ? You've got to ensure your specs are bulletproof, leverage those OEM advantages smartly, and always demand rigorous testing. Thanks for joining me today, and we'll see you on the next deep dive.